Yeah.
Yeah, thank you for attention to our project. So there was a discussion about electrolyte standardization, I think 5 years ago at Benetech meeting, but we couldn't find any project and we couldn't find a budget for this work. This year we have received the financial support from a German federal ministry to work on standardization. And could you please go to the next slide? So we can work on standardization together with the company GFE, who is an electrolyte producer and who can produce electrolyte based on a preset specification in the frames in the context of this project. We have also a company, First Flow Energy Solution, who is able to make validation of prepared electrolyte based on a preset specification. And this project is planned for 2 years. This is a short project. And there are 2 activities which should go in parallel. The first one is a continuous work on standardization. And in parallel, we wanted to check what kind of electrolytes are already available at the market, what kind of metrics do we have now. Then we wanted to compare different analytical methods and procedures which can be applicable for electrolyte assessment. Then we plan to define some kind of average or average specification which could be taken as a draft for standard specification. And then finally, we have to validate our electrolyte or evaluate electrolyte performance in industrial scale. Could you please go further? So here you can see the steps which are necessary for the work on standardization. Actually, this is a many-step process, and each stage, so we have to go through the 9 stages, and each stage may have up to the 7 sub-stages. So now we are at the stage 10.00. It means that we have initiated new work item proposal by DKE. DKE is a German Commission for Electrical, Electronic and Information Technology. This is a member of International Electrotechnical Commission. And our proposal is still under consideration. It means that we are waiting for a decision if we are allowed to make standardization work on international level. If we get a refusal, for example, at this stage, we still have a chance to make standardization work at the European level. And finally, in the worst case, if we get refusal for European level, we still have a chance to make standardization in a national, in German level. Could you please go further? So firstly, I have to precise what we mean if we speak about electrolyte. So for us, electrolyte is a solution which contains vanadium salts. That is why we speak about total vanadium concentration. It contains also sulfate and free sulfuric acid. This sulfuric acid plays essential role for electrolyte performance, but it shouldn't be confused with acid taken to dissolve vanadium components for electrolyte preparation. And free acid is not directly measurable in practice. That is why we measure total sulfate concentration as another electrolyte metrics. Then some electrolytes contains phosphoric acid additive as a stabilizer, and electrolytes have impurities. So for this project, we have contacted various electrolyte suppliers worldwide, and we have received 9 samples from 6 different suppliers, from United States, from Europe, and from China. So our common requirement was to get electrolyte based on sulfuric acid. We cannot consider at once electrolyte based on mixed acid. Then we have preset total vanadium concentration in a pretty narrow range, And we have preset also total sulfate concentration. And then we wanted that electrolyte would not be shifted, so that the ratio of vanadium +3 to vanadium +4 would be around 1:1. Could you please move to another slide? Yes. And in this table, we have collected a list. We have listed the procedures which we would like applied for electrolyte characterization or to get electrolyte basic metrics. So firstly, we define the concentration of the mined components. These are vanadium, total sulfate, total phosphate. We try to apply different procedures like titration, like ICP-MS analysis, like thermometric titration, because we know that the application of ICP-MS is challenging because electrolyte is a very concentrated solution. And we use in this case the offer from the certified laboratory Eurofunds in Austria or Germany, because it's important for us to analyze all the electrolytes under the same conditions in the same laboratory. Then we estimate the concentration of impurities, also by ICP-MS. We check also the physical properties by determination of density, conductivity, and viscosity. We try also to check the level of organic impurities because, to our mind, their presence can be crucial for the stability of electrolyte at high state of charge. Then we want to check if electrolyte has insoluble residues. We try to apply the dynamic light scattering procedure for these solutions. Then actually in our practice, we have seen electrolyte which had sulfur containing impurities, and by charging in the cell or by cell operation, this kind of electrolyte can expose the sulfur containing gases like H2S or CO2, and also shift the state of charge. Actually, we have already performed the charge test using the special gas tube sensors for H2C or SO2, and we have not detected such gases in our electrolyte samples for this project. Then the next test would be thermal stability at elevated temperatures. In this case, we also have to charge electrolyte in the cells to get separately analyte and catalyte samples. And we are still on doing these trials. And then finally, we want to evaluate electrolyte performance in the cell. We are currently discussing what could be the performance indicators. If we perform just galvanostatic charge discharge cell, we have currently the 40 quadrat centimeter cell as our standard laboratory cell, but we have to perform this cell with tests in the coming months. Then please, could you go further? So this slide is just to give an idea what kind of electrolyte do we have for this project. So you can see here the principal metrics, the total vanadium concentration, the ratio of vanadium +3 +4, and total sulfate and total phosphate concentrations. You can already see some discrepancy by application of different procedures. For example, titrimetric procedure gives other results than ICP-MS. We still perhaps have to find a reason or explanation for it, but this is just a fact. Could you please move further? Here you can see the conductivity and density data for our electrolytes. So surprisingly, the conductivity was in a pretty narrow range. And we have, I would say we have the same for density. And then actually, I would not go now into details, but I'm open for the contacts via email if somebody has questions. And then to another slide. And here you can see the result of the ICP-MS analysis of detection of impurities. So red colored, we have analyzed almost 36 elements, and red colored points are values which are below detection limits. We have seen for some elements like copper or like nickel, we have like iron, for example, we have a discrepancy, we have some variation of concentrations. And that is why we have put on this plot also the data from the Chinese national standard. They are already available because this standard exists starting from 2018. What we see is that almost all the samples have the impurities below this standard. And perhaps we will consider the upper concentration limit for impurities, or we will try to introduce in the same way grade 1 and grade 2 for electrolyte with different purity grade. So this was my introduction. This is the current state of art in the project. We are still working on it, and perhaps in the coming months we are able to speak about draft specification or perhaps cell performance indicators.
Thank you very much, Natalia. I appreciate the update on your efforts. I know everyone's eagerly anticipating and looking forward to results and proposals. We'll have another energy storage webinar next year, and maybe we can get your final results and recommendations at that point. Again, if you have any questions for Natalia, you see her contact information here. You can also
perhaps I have to add
yes,
that to my knowledge, the standardization process can take from 3 up to 5 years, based on just for standardization work, because we have to make steps, we have to wait for decision from standardization committees.
Yeah.
So our project will be finished in 1.5 years, but we still we will still proceed this standardization work.
Great. Thank you very much. And again, if you have any questions for Natalia, there's her contact information, or send her a question in the Q&A. Thanks, Natalia. I appreciate the time today.